Yes, we are able to see it.
Okay. So today we are going to just briefly talk about data science for mental health. At the end of this talk, what I would expect from you is at least to gain some understanding on the relationship between data science and other disciplines. Also, identify some of the skill sets you need to become a data scientist, and also at least have an idea of some of the tools you need for various tasks in data science. Then I'll conclude by highlighting some of the online resources you might need. And at the end of it, if we have some time, you should be able to install R and R Studio. That is, if you don't have them installed. So in terms of the outline, we'll start by a brief introduction, giving you some key insight on how the data science discipline came into being. Then we'll talk about the current landscape, what is there, what needs to be there. And then we'll look at the relationship between data science and other disciplines, then take you through a process of becoming a data scientist and how do you stand out from the rest. Then we'll conclude by looking at various data science tools. I hope up to that point we don't have any questions, and at least we have a clear picture of what we need to do and where we'll be at the end of the training. So within the slides, I'll post some questions, and way to respond to these questions, you just type this or you scan this QR code. If you have a phone, you can just scan this QR code or just type poll everywhere. Then at the end of it, just do /SYGU139. Or you can use your phone. You just text this to this particular one, but it will charge you. So you better use the browser. Once I activate the questions, you'll be able to get access to the questions, and then we do live response to various questions. So just as an introduction, for us to talk about data science, then we need to talk about data. And for us to talk about data, we need to talk about sources of data. Where we are, what we are currently doing, we are gathering data even from Zoom. We know that it collects information about the participants who attend. So we can use even just Zoom and gather some data which we can do analysis on. That's just an example. But if we take a step back, we go into different sectors, then maybe we would start by looking at healthcare. So in healthcare, we have various data sets ranging from demographic health records, or even things like smartwatches you wear nowadays have some kind of tracking devices which can help you monitor your health. So those kind of devices collect data sets which can be used for various analyses. Then we also have our phones. There is always a saying that if you talk about something so much on your phone, the next time you go to Facebook, you'll see some advert around whatever you are talking about. How true that is, I don't know, but we know that our phones collect information, and those information are data. Then for those of us who are old enough, we know things like floppy disks or hard disk, at least we know, and also cloud storage. So those are some of devices we can use to store data, and they also contain data. Then we have social media. So we know there's some analysis on X platform where you can even do predictive analysis on the kind of products you advertise on their platforms, or even Facebook or Twitter themselves. they use the data from the things you click and do some kind of analysis. So all those social media platforms generates a lot of data every second, and those data sets can be used for various purposes. Then for those who do online transactions or those who have credit cards, as you pay for your shopping or bills, there are data sets which are generated, and those data sets can be used for various purposes. We have things like streaming websites also collect a lot of data. We have platforms like the ones we are training on, education platforms. And in general, what we can say is that every day, every second, the data is generated. And if we don't think about ways to utilize this data, it is not going to stop. We have to think about better ways to utilize the data. Then for us to talk about data science, then we have to know how did it come into being. So we've talked about data, but the other aspect of data science is the emergence of new technologies. So long before, maybe 10 years ago, or maybe 10 years is soon. So let's say 20 years ago, you could not be able to maybe store 10 MB of data. My PhD supervisor used to tell me a story on how they used to queue to just analyze or run a regression table. They would queue for almost 2 months just to get a space on a computer where they would manually punch the data, and it could only store maybe up to 1 MB of data. So they would queue there for several months, just waiting for the computer, one computer in the entire university, to be free for them to run their analysis and so on. But nowadays we can even store terabytes in our phones. They are powerful phones which have up to maybe 10 terabytes of space. Some have even RAM up to 256 gigabytes. Then we also have Internet of Things. So I've talked about phones generating data, but even the devices we have in our homes nowadays, you can remotely control your washing machine or even coffee machine. But as you do that, they generate a lot of data, which you can use for the analysis. But again, what is important is the emergence of artificial intelligence, which we'll talk about in details. But for us to talk about data science, then we can't talk about it without talking about artificial intelligence. Please feel free to interrupt if you have any questions. I'll just check on the chat if there are any question. Oh, so there are no questions. I'm not audible, so I'll try to be audible, but I hope I am. Okay, then for us to talk about data science, the other aspect, so apart from data sources, emerging technology, we have to talk about the big V's. So there are several V's, but the key ones we have to talk about are the first three, which are volume, velocity, and variety. When you talk about big data, then you are talking about the size of the data. The size of the data can be in terms of the number of dimensions. So how many variables do you have? Or the number of observations. So how many unique observations or rows of data do you have? Then we talk about velocity. So velocity refers to how often do you collect this data. So if it is maybe time series data, how often do this data come in? Then variety is about how different is the data set. So maybe you could be collecting data about households, you could be collecting data about individual purchase or health information about individuals. But how can you merge these different data sets maybe into one and use them into analysis? So there are other aspects of these, but the key ones are the volume, velocity, and variety. Okay. So how did data science come into being? before we talk about that, then we need to think about the data, the big data we've talked about and variety of data we've talked about. So need to process and make sense of data is one of the things which we have to think about before we even think about data science. So we've agreed that there are various data sources, there is technology, and there is big data. For us to use this data, then we have to think about data science. So data science, if it is able to integrate various different data sources. So for example, if we have data set from healthcare, we have data set from weather, can we merge all these data sets and make sense of them? Then how can we utilize various tools to either mine? So mining data just refers to how you gather data from different sources. It could be from the internet or from other sources. And how can we make sense or generate insights in terms of analytics, visualizations from these data sets? But at the end of it, what you want to achieve is to help businesses or help institutions or help government institutions make policies which can help them either increase profits or improve livelihoods of those who are affected by the data sets. So the key reason why we need data science is to be able to extract insight from the data, which can help us solve various world problems. So it could be we want to predict disease outbreak, or we want to come up with interventions based on data, or we even just want to visualize data and inform people based on our visualizations. So what is data science? But before we talk about data science, then we have to think about the power of data. So data has the power to improve business if effectively utilized. If you properly analyze your data and you have the right model, you have the right tools, you can be able to inform businesses or even guide them on how to improve their efficiency for optimal profit. Then we know that data has patterns. We can't see them by just looking at rows and columns of data sets. But if we use data science tools, we can see hidden insights from the data sets. And also, if we have efficient techniques and tools needed to uncover hidden insights, we can be able to generate information which is key to institutions and businesses. So in brief, just to define what data science is a field that uses domain knowledge, statistical and computational techniques to extract insights from data. So highlight the three key components, which are knowledge, domain knowledge, statistical and computational techniques. You can't be a data scientist without understanding the domain you are working on. You can be good in writing codes, but if you can't make sense of what data you are using or what you're working on, then you are not a good data scientist. Then you need knowledge in statistics to make sense of the output. So let's say you generate tables or figures, or you have predictions. Can you relate them can you give statistical meanings to the outputs and say, based on this, I'm maybe 95% confident that my outputs will be correct enough. Then you also need the computational techniques. So you need to know how to write codes or even use the existing softwares to be able to analyze or utilize data. So we want to at least go through the landscape of data science. And in the previous definition, at least I've covered a bit of it. But from this figure here, I hope you can see my cursor on the left. we see that data is everywhere and we can generate it from almost everything, ranging from roads, phones, social media, weather, and climate. And in this, we generate what we call big data. But for us to understand the data, we need data science. Data science doesn't come as a standalone discipline. You need some knowledge in maths and statistics, some knowledge in computer science, some knowledge in in the domain, and also a bit of software development and machine learning. So we'll talk about this intersection in the next few slides, but as you embark on this journey of becoming a data scientist, just know that it is something which people have been talking about as one of the best disciplines or courses in the 21st century. So at least this should motivate you, as much as it might be a hard field to go through. You might end up being in one of the best fields altogether. Okay, so I've talked about this particular intersection, but now I want us to go into details. So in the data science is the shaded one, but we see that it is not a standalone subject. You might need some little knowledge in data mining. For example, you have some data sets you want to extract from various websites. Then you might need some skills on how to extract that data. There's also aspect of visualizing or looking at the data set you extract. There's aspect of data management or what we call data processing. Then you also need some skills in AI and machine learning. There's also aspect in pattern recognition and statistics. So this is just some of the disciplines which, at least as a data scientist, you need some little bits in it, or you can decide and specialize in one of them, but at least you still need skills in other aspects. Okay, so this is the first activity I would like us to go through, which is, as a data scientist, which of the following skills do you think are important to you? So you just need to type polleverywhere.com or polleverywhere.com/Cygu 139, and then respond to the question. So I'll just go switch my tab and see whether you are able to see the screen. Let me share the screen. I hope you've been able to type that. So once you type it, you should be able to see some question. Let me activate it. Okay, sharing. Okay, so I think once you activate it, you should be able to see such a screen, and we can see at least there are some responses. So you just need to type this on the screen and then respond.
Some are asking for the link again.
So the link, I'll just put it on the chat. Okay, I'll put it on the chat. So I think we can see at least majority think that maybe what they need is the analytical or analytic skills. Then we have also a good number indicating that they need problem solving skills. None thinks that we need communication skills. We also have those who think that at least we need to be curious about what we do. So I'll just stop sharing this. You can continue sending your responses, but we can go back to the slides. So. Okay.
Steve, there's
So,
someone with a question. I don't know whether you'd like us to take it before you move to the next session.
sure.
Beryl,
Yes.
Beryl, you can unmute and ask your question. Beryl Mungai. Beryl, are you there? Okay, fine. We can proceed. Sorry.
So this just relates to the questions or the question we've looked at. But what I can say as a data scientist in this particular field, in no order, you might need to be an all-round person. So you need a bit of domain knowledge to be able to at least understand what you want to talk about or want to analyze. Then once you do your analysis or once you make sense of data, you should be able to communicate your finding to the people or to the policymakers. As part of the communication, you should also be able to present your finding. One of the things which most data scientists or technical people struggle with is the ability to communicate the finding and ability to write, put into writing what you've worked on. Then you should be curious. Data should excite you, and you should, once you see data or once you have results, you should be able to question every bit of your results, whether correct or wrong. You should be able to know, why is this correct? Why is it wrong? If it is correct, then how correct is correct? Or if it is wrong, what is the potential solution? Is it that I don't know how to do it, or can I get solution from somewhere else? Then you should be able to at least have some analytical skills to be able to do the analysis. Another bit of it, which is very important, you should have problem-solving skills. So once you are presented with the information or the data, are you able to translate that information into problem and at least come up with some hypotheses on how to solve or come up with a solution. So in the past, maybe 10 years ago, what we thought of data science is just having some knowledge in statistics and being able to do some traditional analysis or being able to do some data manipulation, parsing, scrapping, and data formatting, and being able to at least visualize some data using various tools. But currently, what is important is being able to be creative. So mostly data science problems needs you to think outside what you're used to. You should be able to creative, and as per Albert Einstein, if you can imagine something, then maybe you solve all part of the problem or halfway it is solved. As he says, imagination is everything. It is the preview of life's coming attractions. If you can imagine something, then you are able to think about it. You are able to at least have part of the solution as you think through the problem. So as you think of becoming a data scientist, know that there is aspect of it which involves being able to be creative and imagine what you can do. There's one problem I'm working on, which is building some kind of codeless platform for machine learning and AI. Every time, like if I just sit alone, I just think of how well can I improve this, maybe this bit, how well can I maybe make the data upload page be more friendly. So because it is something I really want to do, every minute I have to think about it. And that's how, if you're interested or you're curious about being data scientist, you'll be thinking about your problem and how to solve it. So as we start this journey of becoming data scientists, I know some of us already a data scientist, but I want to assume that at some point you started from somewhere, and there are majority of us who are starting or are somewhere but still wants to improve. You need bit of maths and stats, and the aspects of maths and stats you need to be able to run various statistical models. It could be maybe you are able to fit linear regression, you are able to fit logistic regression, or you are advanced enough and you are able to fit maybe multi-level mixed models. You are able to design experimental designs and do those kind of randomized block design analysis. You're able to run surveys, not collecting data, but do survey analysis or survey designs. Then maybe you are very advanced and you are able to run Bayesian inference. So you are able to do the kind of Bayesian analysis we all know. But you could be in starting your journey in data science, which involves knowing a bit of statistical learning. So statistical learning can either be supervised, where you have your outcome of interest, you know what you are looking at. For example, you could be looking at maybe whether an epileptic person would experience the seizures or not. So you have a bunch of clinical information and you want to know whether maybe this particular person would experience seizures in 10 days to come or in next 5 days. So at least in that case, you have the outcome of interest. Or you could be able to, you want to run unsupervised learning where you don't have any key outcome of interest, but you want your machine to identify for you the patterns in the data and be able to make or generate clusters which can be linked to something which is known in the domain. So for example, you collect gene data, so you have maybe 1 billion genes, and the matrix, maybe it is 1 billion by 10 kind of data. Then you want to run this through a model and you want it to be able to categorize for you individual and say maybe in this particular group of people, they are able, or you'll see this kind of health problem or mental health illness. Or you advance and you are able to think of algorithms. And once you think of this algorithm, you are able to build or implement various optimization problems. It could be just simple least square, or you can do complicated things like gradient descent and its variants. The other aspect of it is being able to use or program using various tools. So you need a bit of computer science basics. You don't have to be a computer scientist, but at least you need the basics of understanding maybe how to just write a skeleton code without necessarily programming it, then at least you need a bit of some knowledge in one of the scripting languages. It could be Python, or you could do C++ or C, and also some skills in various statistical computing packages. We have R, Stata, SPSS, then the database knowledge in things like SQL, NoSQL, and also a bit of knowledge in cloud computing. So you might not have all these. Me personally, maybe I don't have all these, but at least you should be aware of such things exist, so that when there is a problem and you need to solve, you know where to start from. So at least I know that if I need to implement a cloud kind of computing infrastructure, then I would think of something like AWS. Or if I have to have a very huge database or data set, I don't have to save it or run it on R. I can just implement it in various databases and call that through R or Python and so on. Then the other aspect of it is being able to have some domain knowledge and a bit of soft skills. So one, you should be passionate about what you are doing, or science. At least it should excite you, not that when you see scientific problem, then you're just like, no, this is too hard, I can't think about it. You should be curious about data. At least we've talked about being able to be problem kind of solver. Then other aspect which we've not talked about is being innovative and collaborative. Some of these problems are not so easy to solve. Maybe you can take years or months to solve, but if you can collaborate with others through different platforms, then you'd be able to learn quickly and be able to do data science. Then lastly, we have aspect of communication and visualization. So once we generate our insights, we come up with very nice models, very predictive models. Are we able to tell a story out of the data? There is aspect of data science which is also interesting, is about storytelling with data. Actually, if you happen to know anywhere which that course is offered, please take some time and maybe register for such course. You can reach out if you're interested. I know someone who would offer that course on storytelling with data. It will help you at least make stories out of your data and be able to communicate to non-technical people using your output. Then the other aspect of that is being able to translate the insights into decisions. So you don't just want to have outputs. These outputs should be actionable, and you should be able to at least inform policy based on that. Then being able to at least do visualization. They say by just using one picture, you can communicate 1,000 words. So if you are able to visualize data into very appealing visualizations, then at least you are communicating with those who are non-technical. So there are various tools in R and Python which you can use for that. Okay, this is the next activity, which is why, if you want to become a data scientist, why do you want to become a data scientist? I'll just go online and activate that question. So it is about why do you want to become a data scientist? Please go back to the link and so I'll stop sharing the slides and share. Okay, so I'll paste the link again. So there's a question about me explaining more about hacker's mind. So we know that hackers are always curious. At times they don't even want to cause harm, but they just want to show you that they can do it. So as a data scientist, what you should think of hacker is not being the negative or the bad person, but that ability to always, when you see maybe something, you're just curious, can I have a solution or can I get into this? So when you see data science problem, you should think of it, can I be part of the solution? Can I get into the challenge? There are various data science challenges online. Can you think of it and be like, oh, I want to be part of the people who are competing or coming up with a solution? I hope that answers the question. Then there is another question. Yes, so there is someone who is Eden Kojo, who is interested in learning storytelling with data. Okay, you've included your email and reach out to you after this. Any other question which I might have failed to answer? Okay, so we can all see the responses, but majority think that they want to get into data science because they are passionate about it. Others have other reasons, but surprisingly, there are some of us who think that it pays more. That could be a shock to you, but let's just go through the slides. Maybe at the end of it, we'll know better. But thank you for at least responding to this. I'll switch to our slides. Share. Okay. Okay. I hope I will switch back to the slides. Okay. So as we start our journey, there are some key aspects which are very important. We've talked about being passionate about data, then being able to think through the problem. We've not talked about being a good listener. Usually, as a data scientist, researchers will come to you with their problems. But if you can't listen and try to understand what the context is, what is the main scientific goal, then you could be in trouble. Then we've talked about being a good storyteller or having data storytelling skills. We've talked about being technical in coding and data analysis. But I really don't like this aspect as much as you are obsessed with solving problems. Don't be quick to Google or to ask Google. We know that now there is ChatGPT, there is Stack Overflow. You can always find solutions there. But the reason why I'm discouraging you on being quick to that is because you won't think. So let's say you wanted to implement your own code to run linear regression, but you understand the algebra, you know how to use R, but maybe there's just one bit which is not working. Instead of trying to figure out how to make this work, you go to Google, you'll find the solution, but you won't understand the whole problem. I always believe that if you spend some time trying alone. If you don't get the solution, then you go to the Google, you'll understand why your solution was not working, and you'll understand more. Then lastly is about collaboration. So data science is a new field. Some of the tools or ways to solve problems are not yet there, but if you collaborate with others, you might be able to come up with solutions. You might be able to build new models, or even come up with better models. But what data science is not equal to is big money or more money. Don't expect that if you are a data scientist, then you'll be making more money. If money is the driving force, then maybe you'll get your first salary for the next 4 years or 5 years is not good. You'll run away and you'll not be a data scientist. But if you are driven by passion and also interest in data, then money will just be part of it. Money will just come. So don't be driven by money, be driven by the other things, then let money follow. That's what I think, but maybe I'm wrong. Any question up to that point? I think there is a question here. So Michael Njenga would be interested in learning more about data science and storytelling. Okay. Michael, I'll reach out to you on this. Then can you please reach out to me about course with data science? I think I'll link. I'll link up with Kuria, and he will at least provide more information in another session about storytelling with data and how you can go about it. Then question from Andrew. I think most times we have the theoretical knowledge. The problem always lies in the practical application of the theories. This is very true. And one way, I think there is a slide, I will talk about this, but one way of putting theories into practice is doing, because data science is a practical course. You can't just do it by not doing it. So you have to do it, and you have to put all the theories into action by trying out what you've learned by yourself and so on. Okay, any other question? Let me just check on the chat. Okay, it's just about storytelling with data. Okay, now I know maybe some of us are confused and we are like, I'm a statistician, where do I start from? Or I don't have any knowledge in statistics, I'm just maybe public health official, where do I start from? But we always say, from confusion, there is always clarity. So when you are confused, by the end of it, things will be clear. Being confused means that you're thinking through it. But there are various stages where we can start from. You can decide, and maybe you just have basic knowledge in statistics. Then what you would want to do is to improve your skills in statistics by maybe being more practical, using R, using SAS, using SPSS, or just being good in Excel. That could be one way to start from. So you make sure that whichever stage you are in, you are perfect, so that when you are moving to the other stage, you are better off. But you can't jump. Maybe you don't know how to use R and you want to maybe just start by being machine learning engineer and so on. At least start from where you are and build from there. Or you're already okay, but you want to think of, I want to be a data scientist, or I just want to be a data engineer. So if you want to be a data scientist, then at least be good in your analytics and technical skills to extract data, analyze, and model. Be able to build various models, predictive or inference-based models. And you can maybe do this in R, Python, MATLAB or Tableau, Spark, and even more recent software, which is called Julia. So Julia kind of intersects between R and Python, and it is kind of good. Then maybe you just want to jump into being a data engineer. So you are responsible for building data architecture. So maybe you're thinking about big data sets. How can you build systems which store such huge data sets? Or you want to be able to integrate data sets from various sources, and maybe you have data set from this source, you have servers which connects various data sets and applications. There are various tools to do that. So depending on where you are and where there is confusion, you can decide and start from somewhere and then jump along the way. I think this slide is repeated, but for this particular slide, what I'm trying to say is that the journey is kind of long. It has various starting points, but you can start from anywhere depending on where you are. So, for example, let's think of someone who just has fundamentals. So he just has fundamentals in linear algebra, maybe binary tree, algebra, DB basics, tabular data, and so on. So if you are in fundamentals, then maybe you can just start from somewhere, then you move along the way until the point where maybe now you get to statistics. So you started from just basic matrix operation, then you are somewhere into ETL. So ETL deals with how you explore, transform, and load the data. I think so. So here at this point, maybe you are 5% along the journey. Then you are now into exploratory data analysis, and or you branch and continue with this particular journey. You are now more into statistics, or you go into programming. So depending on where you are starting from, you can always jump, branch, or stop, or continue. But you can start from anywhere along the journey. There are so many starting points, but it all depends on where you are. So in summary, this journey is not linear. It is not one-to-one. I cannot tell you that you can start from point A and end at point B. It depends on where you are. It depends on where you want to be. There are so many branches along the way. So you can start from anywhere, but just know it is not a linear path. It is not about having just one particular skill. What you need to know is you need so many, at least to have idea of so many skills, but be good in one of them. So at least know everything. Know that there is aspect of machine learning which requires me to know how to split data set into training and testing, or there are things called decision trees, there are things called random forest, there are things called large language models. But at least be good in one of the skills, so that if I need someone maybe who is good in large language models, I know that there's someone there. But the person might not be good maybe in data management. So I need to have someone else to help them in data management as they build for me the large language models. So the key thing is at least know all and be good in one. Then the other aspect of it is that this is a very evolving field. Last year, we were not talking too much about large language models, but now we think about, how can we build large language models? How can we are even forgetting about ChatGPT, because now people are customizing their own large language models. So as you embark on this field, just know that you cannot just be comfortable. Every day is a learning day. You have to learn new things almost every day. So this is just at least a summary of the previous slide, but what it shows us is that we are at different stages of this journey. There's someone who is in stage 1, there's someone who is in stage 4, there's someone who is in stage 6. But depending on which stage we are in, we don't know where it will end. What is important is you are in a stage. You just need to know that it is an evolving journey. You just need to keep on moving. So for example, there is someone who is currently in basic statistics and programming. What they aim to understand or to know now is to be able to understand basic maths and statistics and then move to visualizing data. There is someone who is good in database and ETL. So this is just evolving field. Last year when I was making this slide, I had not thought about large language models. Now we are no longer, at least large language model is part of AI, but it is a different field. So maybe I need to add another arrow here showing that at least we are evolving into large language models. I don't know what will be tomorrow, what will be the next step tomorrow, but it is an evolving field which keeps on growing each and every day. Are there any questions? Okay, so I'll pause just a little to see. Also explain, me too interested in data science and storytelling. Also explain between data science and data analytics. Then, okay. So I don't know whether you want to understand the difference between data science and data analytics. So data science is like the general, which includes almost everything. So in data science, there is aspect of machine learning, there is aspect of AI, there is aspect of analytics, there is aspect of statistics. But for analytics, you're just focusing on one area of data science, which involves generating insights from data. So in data analytics, what you want to do is to get data and then generate insights. For data science, you're thinking about building systems which can handle data, building tools which can handle data, generating insights from data, communicating this particular data. But analytics is just a subset of data science which focuses generally on generating insights from data. Any other? Let me just see if there's another question. So there's another question. What is the striking difference between ML and AI? So ML is a branch of artificial intelligence, but generally what we are thinking of in artificial intelligence is giving the computers ability to do things without necessarily telling them to do. So you train a model on how to predict something. Then next time you have data, you don't have to train the model again. You just give it the data, then it will do the same thing. So ML is just a subset of artificial intelligence, which deals with which focuses mainly on application of various machine learning. So machine learning are just models which are aiming at understanding data and making prediction from data. But in the AI world, you can think about building robots, automotive cars, or even coming up with large language models which help you understand, like trying to imitate how human would think in real world. There's another question. It will be good if we can answer this question with an example, please. Okay, so I think I've explained the difference between ML and AI, but a good example would be, let's think of an example where we want to predict whether a patient would experience seizure, so epileptic patient would experience seizure or not. What we would do is to train a machine learning model or a machine learning algorithm. And next time we have maybe information about another patient, we incorporate this data, then it would be able to tell us that this is the likelihood of this person experiencing seizure. That is one. But this particular model is a subset of AI tools. So ML is just a subset of artificial intelligence, which aims at making computers smart as human, or trying to replicate what computer would do without being supervised by human. I don't know whether that answers your question. Okay, so I'll continue. If there's more clarification you need, please put it on the chat. Okay, so as we think of starting our journey of becoming data scientists, we have to think about where can we start our journey. There are various online courses. Some are free, some are paid, but there is also aspect of learning from YouTube and so on. So we have DataCamp, we have Coursera, we have EDX, we have UCT, we have LX. There are so many of them. These are just a few. And for those who have at least have some knowledge in data science, then there are other sources or resources to access data for practice. As we mentioned, that data science is a practical subject, which needs you to continuously practice and implement various algorithms. So there's Kaggle, there's UCI, there's MLCom, and so many websites you can generate or you can get free data from. So these are just some resources we need as we embark on this journey. So for us to go through the whole journey, we need to know every bit of it. What skills do we need and where can we get the skills from? So if you want to learn about basic statistics and programming, then the tools you need to learn are R and Python. You can learn this from DataCamp. There is a course on Introduction to R. There is also another course on Introduction to Python for data science. Then in Coursera, there's also a course on R programming. There's a course on Introduction to Data Science in Python. Then EDX, there's a course on Introduction to Python and also a course on Introduction to R for data science. But at the end of this training, then you would be able to learn about the benefits and software capabilities. So you'd be able to know what R is capable of doing and what Python is capable of doing. Then you'd be able to know about general knowledge about the field of data science and how to use the various tools. Then you get an understanding of how various or the code basics, syntax. So for example, if you have to implement a function in R, how do you implement it? If you have to write a for loop in Python, how do you do it? So at least this course will help you build the basics you need for data science. Then you'll also learn how to import data into the software. So let's say you've collected mental health data. How do you import it into R? How do you do basic manipulation? For example, knowing how many patients are female, how many are male, what is the age distribution. So you'd be able to at least know that from this particular introductory course. I think I've seen there's a question, are these courses free? Some of them are free, some of them are paid. Then we So I think we need translator here. I don't know who is a translator, but there's a question in French which needs to be translated. There's another question whether I'll be sharing the slides. I think Kuria would respond to that, but I think every material, Kuria would let us know whether they'll be shared or not. Yeah.
Yes, we will share all the materials on our platform. Let me text the link.
Okay. And is there a translator? There's a question in French, which maybe needs to be translated, but we can figure out how to do that. Okay, so next in our journey is learning maths and statistics. So the tool you need, the software you need is R. You can learn a course on hands-on introduction to statistics with R, introduction to statistics with R from DataCamp. You can also learn statistical inference or introduction to probability and data from Coursera. You can learn introduction to statistics, ideas and instruments for statistical inference from EDX. But at the end of it, you'll be able to learn fundamental concepts of statistics such as p-values, variance, correlation, statistical hypothesis, and so on. You'd be able to evaluate various data types and how to interpret the structure, and you'd be able to apply various statistical methods on data. So these are some of the things you learn from maths and basic maths and statistics. Then for data manipulation, mining and visualization, you need R. There's also Power BI, and there is Python. So you can learn data visualization with ggplot2. So this is a library in R which focuses mainly on data visualization. Then you can also learn introduction to data visualization with Python from DataCamp. Then from Coursera, you can learn exploratory data analysis. You can learn data management and visualization also from the same. Then you can learn from EDX, you can learn analysis and visualization, visualizing data with Power BI. Then there's data analysis, visualization, and dashboard design, again from EDX. Then there's another website, which is Udemy, where you can learn Power BI Masterclass for beginners to advanced. At the end of it, you'll be able to handle data anomalies, such as dealing with data, missing data, outliers, and so on. You'd be able to explore the relationship between variables. So for example, if you have gender and age, are you able to look at how they are correlated or if there's any association between them? You'd be able to apply feature engineering techniques on data. So feature engineering is just a term used in machine learning world, which means if you have input variables, so you've observed information or characteristics about the outcome of interest you have, can you make some transformation on those particular variables? For example, you observed age, and what you want to do is to be able to maybe regroup the ages, put them into age groups, or even just transform them so that they're in a scale of 0 to 1, and so on. So just doing some transformation on the input variables to improve model performance and also to improve computational efficiency. So there are things you do, or you remove even redundant. So maybe you have collected, you want to use BMI. We know BMI is from height and is it height and what? And weight. So if you have BMI, weight, and height, then maybe you don't need height and weight. So you can do some kind of correlation between the variables and automatically technique will help you remove what is correlated in that case and only have one variable you need. Then you'll be able to also generate graphs and visualizations and so on. Then for databases and ETLs, so I mentioned that ETL is exploration, transformation, and loading of data. It involves data transformation. So you need some knowledge in SQL and also Python. So you can learn a course on Introduction to SQL for data science and also Introduction to Databases in Python from DataCamp, or from Coursera. You can learn using databases with Python or managing big data with MySQL. Then from EDX, you can learn querying data with SQL. At the end of it, you'll be able to understand how relation databases work. You'll be able to interact with databases for fetching, saving, and manipulating data. So for machine learning, you need to learn R and Python. You can learn a course on machine learning toolbox or a course on introduction to machine learning from DataCamp. There is also a course from Coursera, which is machine learning and also practical machine learning. From EDX, you can learn applied machine learning or principles of machine learning. At the end of it, you should be able to apply various algorithms. There are regression algorithms for regression problems, such as, or you can now learn algorithms for classification problems, or you can learn specific algorithms like random forest or classification trees and others. Then you learn about model training process and comparison of various models. Then you can be able to learn also about predictive modeling techniques. So for example, you want to predict something, given some information, you'll be able to learn about this at the end of it. Any question? Let me just see. We still need to translate this, but we'll get back to it. So, okay. There's no particular question. Okay. So for AI, you still need R and Python. There are various courses you can learn. Again, from DataCamp, we have text mining. There's introduction to deep learning. There's manipulating time series, data in R, and also the other courses like from Coursera, like deep learning specialization. There's practical time series analysis. There's also ADX, which is offering deep learning explained, graph algorithms, and so on. At the end of it, you should be able to manipulate and structure data, understand deep learning, social networks, and text mining and time series, and so on. Then what would be good to have, as much as you are learning new things, at least it would be good to have some knowledge in R and Python, then be able to build simple web application from using R Shiny, or these other library in Python, Streamlit, something Stream, which can also help you to build simple web applications. You should be able to at least know how to build simple chatbots in Python, do some bit of network analysis. There's a bit of credit risk modeling. So for example, if you want to build systems for banks on whether they should loan people or not, at least you should be able to build such kind of models. Then you can learn all those from DataCamp, or you can learn Bayesian methods for machine learning from Coursera, and also practical reinforcement learning from Coursera. At the end of it, you'll be able to have some problem-solving skills which are specific to particular problems. So maybe you don't have any experience. So how do you start your journey without any experience? So the first thing, at least have some basics of what we've discussed, but one way to move forward is to build a portfolio of your personal projects. And one way to do that is to have GitHub. I hope we all know what GitHub is. So GitHub is just a platform for version control, but now it also has like kind of a server to host. You can host various projects you've worked on and just put them there. And people would see, as a data scientist, if you are coming for interview, the first thing we'll ask you is, do you have GitHub account? If you say yes, we'll go ask you for the username. Then we just go and see what you have there. So it's a way to show your work, and one way to build your portfolio is to have. So this is just an example of my own, but you can also build your own website for that. Then another way is to collaborate in open data science projects. So I mentioned about Kaggle and other platforms. There are always competition, and you can always. Sorry, I think there was a problem on one of my devices. Yeah, so there's always competitions, and you can always take part in those competitions. And one way to do that is to collaborate with others and work on particular projects together. Then the next is to volunteer. As much as some of us indicated that they are more interested in money, but one way to learn is volunteer to do some projects just for free and learn on how to solve various problems. Then we talked about data science being a practical subject. So you want to apply various techniques and solve real world problems or work on case studies. So maybe there is a challenge, you get involved, and then you solve and come up with a solution. Then I always believe that one way to learn is to teach. Yeah, so you grow by teaching. If there's something you've learned from this training or you've learned from me today, go tell another person. As you tell the other person, you'll realize maybe you didn't get it as you thought. So maybe you go back and go through the material again, or the other person will help you get another perspective or understanding the same problem. So when you teach others, you also learn and also grow by teaching others. Then I've talked about collaboration, but another way to think about it is have network. So have group of friends who work on the same or are interested in data science, talk about emerging technologies, and try to solve problems with them. Then I've mentioned about competition, so I'm not going to repeat that. Yeah, so where can we compete or get data to compete? There is Kaggle competition. So if you type, you'll just see they always come up with challenges, and then people collaborate and solve problems. So one way to learn is go through this kind of challenge, try to come up with a solution and see what others are doing. Maybe you'll realize, oh, so I thought I was bad. My solution is even better than others. So you can always go to Google, pick particular challenge, and then try to solve it. You can even solve one which has already been solved and see whether your solution is better than what was proposed as the solution. That is one platform. There are other platforms also for competitions. Then other than Kaggle competition and the websites I've mentioned, there are various platforms which can help you learn. There's what we call KD Nuggets. So it is a platform which just post questions about data science. Some of the paid version of those platforms I've talked about are free in most of these. Analytics video used to be free, but now it requires you, I don't know, to sign up using your email address. But still, it is a very good platform for starting or learning data science. There is no free hunch. There's R bloggers for those who are interested in R. They have a bunch of solutions to almost everything. There's Fast ML, there's Data Science Central. So all these are free. But as much as I said, don't be quick to Google. Always when you're stuck, try Stack Overflow. It has almost solution to most of the things. Even if it doesn't have, it will give you some guidelines or starting point on how to improve. Any question? Let me see. Is the GitHub account free? Yes, GitHub account is for any public repo. You have unlimited number of public repos you can create. If you are creating private, I think there is some limit on who you can collaborate, but GitHub is free. I don't think you are doing very intensive kind of analysis where you have terabytes of storage. Then you pay, but for the most of things, for code and all those other hosting, it is almost as free, unless you want to do some kind of enterprise production. Yeah, but it is always free. Okay, of course, I was thinking of using Google Translate, but I wanted to do that at the end of our training. But now that you've suggested, I'll just do it now and see what the question was. We let's see what the question was. Just a moment, let me just answer this. So the question says, hello everyone, there is no, so I don't know, it is not complete. So if there was a question, maybe you should explain more. So the question is incomplete and I will not be able to answer it. Are you still able to see my slides on stand out from the rest?
Yes.
Yes.
Okay. Okay. So right, so it stopped sharing. Let me just do that again. Just a moment. I don't know why this. Okay. I'll just reshare my screen. There was a technical problem. I don't know why. Are you able to see my screen?
Yes, you're able to see your screen.
Okay. Yeah,
Mm.
so there's another question, which is, which of the following tools have you used for data analysis or other works? Again, we go back to the platform and then answer the question. So I'll just activate this particular poll. Deactivate this. Then activate. Okay, so please go back to the poll and Okay, so we can see that at least most of us are using or have used Excel, a good number using Stata. Then we also have at least those using R. None have used Julia or Tableau, but at least there's a good indication of us being or taking the right direction. So I'll just switch to the other slide so that we continue, but you can continue sending your answers. Okay. I hope you can see my slides. So I'll just boil down to some key specific tools and then highlight some of the strengths and weaknesses. This list might not be comprehensive, but at least it will give us some guideline on what is expected. So the first one is the Python, then the second one is R, third one is Power BI, then we have SQL. So for Python, if you are keen into learning it, then it is easy to learn. Also, it is an open source software, which means there are so many people around the world who are interested and can contribute to it. So there is a lot of support. You can ask questions about what you're working on, and you'd be able to get answers from a lot of people around the world because there is a lot of support community. Then it is powerful library for data manipulation, analysis, modeling, and visualization. You can use it for a wide range of application, including web development, building applications, and even analysis or building machine learning models. It can easily integrate other languages, so you can use R with other softwares and it will work well, or you can build APIs which you can integrate on other platforms. Then it is widely used in AI applications. So for most AI tools, they'll use Python as the software of interest. And then it has a few weaknesses. For those who are learning it for the first time, it can be a very steep learning curve, and you might be discouraged. But its benefits outweighs that steep learning curve. Then one challenge with Python is setting up various environments. So Python, you might run into problems because you used a different library version for your analysis. If you update, it doesn't work. Even Python itself, there is always an issue of, oh, I used Python 2 instead of Python 3, or Python 3.5 instead of 3.7. So setting up environments to make sure everything works well is always challenging in Python. But once you get it right, it is always okay. Then it might not be efficient for large data processing. Python is not very advanced in data processing, although there is Pandas library, which tries to help in that, but still you cannot compare it to something like R in data processing. Then for R, at least it is strong statistical and it has strong statistical and visualization tools. You can fit most of the statistical models in R. If you can't, you can easily implement them in R. It is also an open source, hence have support similar to Python. Has wide range of packages for data processing, manipulation, and analysis. It can also be extended and used in other languages, maybe by building APIs or just using it the way it is. Then it has also some weaknesses. Also for beginners, it can have a very steep learning curve. It is not as flexible as or versatile as Python. There are some ways you cannot use it. It can always be slow. So R runs on computer memory. So depending on the capability of your RAM or size of your RAM, it can always be slow. That is a very big problem with R. Then we have Power BI. So Power BI is graphical user-based, and you can simply do your analysis or data management by dragging and dropping, and that makes it very user-friendly. Then it is a Microsoft product, so it integrates well with most of Microsoft products. Like you can generate your analysis and easily integrate them in PowerPoint presentations or other tools. Then it is really great on generating reports, which you can share for collaboration, and also very big on data visualization. It gives you very many options. Then some of the weaknesses, it is not strong on statistical analysis, so you can't depend on it for statistical analysis. The free desktop version, so there is free version and there is a paid version. The paid version, I think, is web-based or something like that, but for the it also has a desktop version, but for the free version, you cannot do so much. You cannot even share your reports and so on. So that is a very major limitation as compared to R and Python, which are free. Almost everything is free in the two. Then we have SQL. So for managing large databases and querying, then SQL is the best amongst all these. It can easily integrate with other tools like R and Python. You can easily call in SQL database. It is widely used in large-scale application in industry and businesses. So for businesses managing huge databases, they largely use that. It requires, as part of the weakness, it requires a good understanding of database management and querying. So you must be able to write those queries and understand them. Then it has limited visualization capabilities. You can't just maybe say, oh, now I'm going to do all my analysis in SQL and so on. It is not designed for complex calculation or models. So those are some of the key softwares together with their strengths and weaknesses. Let me just check if there are any questions. So which course do you recommend me to do for Streamlit at a beginner level? And also is it a must to know how to deploy the model? So for Streamlit, I think there is a website we called, what's the name of that website? I've forgotten, but there's a website for Python from A to Z, which gives you at least some introduction to using Streamlit and how to implement it. Deployment bit of Streamlit is not hard because it is just click. It redirects you to just click and you deploy it, unless you want to do private deployment on your own domain. Then you need to at least learn how to do that. It could be advanced a little bit for that. But for just basic introduction, there's a platform, I'll remember it and put it on chat. There's a website for Python A to Z, which has a very good course on Streamlit and building a Shiny application. If you are good in R, Shiny app already now has integration of Python, and actually you can now build your Shiny app in Shiny app but using Python on the back end. So you can do that. That's another way. And the materials are on POSIT, which is our studio website. You can easily learn that. Any other? So this is about poll only allowing one question. I think now polls are not multiple response, but yeah, that's something I can change later on. Then question from Florence. I mean, can't I just say I will build a model and another person help me deploy it, or a data scientist has to know all? No, you don't have to know all. We mentioned that at least be good in one and at least have idea of other things. Even me, there are models I build, there's some kind of deployment which maybe might require thinking about security and securing platforms or local hosting. Those things, I'm not good at them. So what we usually do once we have our model built or the system built, then we work with IT, people who are in DevOps, then they help us. So there is our own ecosystem of data science. There is what we call ML ops, so machine learning operations. That's someone who is just good in building machine learning models and so on. There is DevOps, someone who is good now in deployment and containerizing all these models and making them accessible. Then there are people who are good in workflows or project management. I don't know what ops, there is something ops in project management, which is managing data science projects. So at least just have idea that such things exist, but pick a particular field you want to be good in and make sure you are really good at it. Okay. Any other question? Okay, so key interest was to at least give you some basics of what you need in data science, and also at the end of it, try to highlight for you how you can use the data science tools in mental health. I believe that we have some interest in mental health, and we want to think maybe we have data sets in mental health, and we want to think how we can use various data science techniques to try and understand mental health. This list is not comprehensive, but at least it gives us some idea on what to do. So one thing you could think about on using various data science tools is in the diagnosis and treatment of mental health or mental illness. So you can build a predictive model which can diagnose whether a patient will develop or is epileptic or not epileptic based on some information. So once you build that particular model, you can take it into a different population with the same characteristics and maybe evaluate what proportion of individual based on the information are likely to have mental health sickness. And based on that, you can come up with some treatment guidelines on how to prevent mental health. Then there is also an aspect of it of identification of cause and preventive measures to combat mental health. So this is actually related to one of the work which has been done at a PHRC by my colleagues, which is called a PINA study. So from a PINA study, what they did was to build, if I remember correctly, to build some predictive models and then identify key important features which would determine whether someone experiences seizures or not. So based on some key features out of maybe 1,000, they managed to come up with only 15. So this particular 15 can easily predict whether someone would experience seizure in a particular time period or not. That's an example of how we can use data science techniques to try and understand mental health. Then there is also aspect of it where we can analyze electronic health records to predict maybe whether someone would commit suicide or not. A good example, there was a study actually conducted through Twitter, now X platform, where based on what people post, they were able to predict whether those people had mental health illnesses, and they would be able to, they were willing or they were planning to commit suicide. So that's another example where you can even see what people post online. And actually, when you go through social media, you can always say, this person is crazy, or based on what they post. But now you can use machine learning and data science tools to actually now build a predictive model which will group people and tell you these people are at risk of committing suicide based on this information they put on social media. Then we have another example where there's a platform which uses machine learning or data science tools for crisis counseling hotlines to help identify callers at risk of committing suicide or self-harm through the words they communicate. So this kind of uses text analysis, and based on how you talk, so let's say you call 911 and you want to report something, or you just call them that you have a problem, they would be able to, based on your words, they would be able to know that, this person, if we delay, they would commit suicide or they'll harm themselves. Then, so it has been actually shown that people are more willing to share information with AI-powered tools than talking to an individual. So for people seeking therapy and going for counseling, there has been development of some AI-powered tools which take people through the counseling sessions and even guiding them on kind of therapy to undertake without necessarily having a counselor in the equation. So people are more willing to go through this because of the anonymity of this kind of platforms, and they are okay of not being judged because they know that this is an AI tool and no one is there to judge me. So there are those kind of tools which have been built for patients who are not willing to walk into a doctor or a counselor for their mental health illnesses, and they are willing to maybe go through that loop of interview with the AI tool and be able to get help. Then the other aspect of it, there's a new technology in wearable devices which will allow, which will monitor your mental health mental health status. A good example, even simple now, smartwatch will alert you if you didn't have enough sleep, or if you struggle to sleep through the night, maybe you are turning on bed throughout the night. These wearables will alert you and maybe let you know that, last night you didn't sleep very well, you need enough sleep, or you stayed late, and so on. So those are just some areas where AI and data science tools are helping us try to navigate this field of mental health. I know there are other fields, there are other ways, but these are just some key areas. If you are thinking about mental health, you have some data. This can help you think through. If you want to replicate something like a peanut study, you can reach out to a PHRC team because this is something they have worked on and they can guide you through this. Any question? Any question on this? So there's a question, do you have a setup kit for R? I think if we have time at the end of it, we'll go through how to install R. So that is okay. Which softwares do you recommend for disease transmission modeling and evaluating strategy for to control or eliminate it? So we have actually at the PHRC, we have a course which is starting in the next 2 weeks on mathematical modeling with special focus on agent-based modeling. For such kind of thing, you want to understand mathematical modeling aspect of it. You can start by learning R because there's software, there are packages for building dynamical models in R like Dissolve and so on. So you can learn R. It will help you do that, but you also need to at least start understanding mathematical models for at least if you want to do dynamical models which have some meaning on how the disease transmit through the population. You can also use some machine learning models, but those ones we can at least you can get some help from online sources. Another question is when you collect data from people through the words they speak, etc., using science tool, is it a breach of their privacy that borders on unethical means of collecting data anonymous through it? So it is not if the patient has consented to it. If you call any bank or any service provider now, the first statement they'll make is this information might be collected, might be recorded for quality purposes and might be used for so on and on. Press yes if you accept. So because you consent, what they must make sure is that they don't use it for any other purpose other than what you had consented on. So I believe for even for 911 or these emergency services, when you call them, they always let you know that, oh, this information is going to be recorded and might be used to improve our services. And please consent if you're okay with this. So there's some consent on that. Also, let us try to install Python and PyCharm together. That is, we might not be able to do that today. Yeah, because of time. I can share a link on how to do that, but we might not be able to install PyCharm and Python. PyCharm is tricky because I don't know whether now there is a free version of PyCharm, but last time I tried installing it, there were so many issues about first registering and so many other things. Then I would be interested in joining mathematical modeling workshop. I am an MSc biomathematician student. Kindly link me. So unfortunately, the registration process is closed. So I think, but we have another cohort, I think in the next, how many months, 6 or so months. Please be on the lookout for advert from a PHRC and make sure you apply. Yes, slides will be shared. Any other question on Q&A? Let me see. We are trying to apply an NIH grant for training for data science training. Is it okay if we can collaborate? As I can see, you have a very good understanding of data science. My email is this. If you be interested in collaborating with us, I work for an organization called Human Virology in Nigeria. So Nafata or Andrew, I think, I hope I pronounced your name well. I'll reach out and APHRC is always open to collaboration. So I'll reach out and we can talk about this. Any other question? Okay. So We've gone through most of the materials we wanted to go through in this session. Because we still have some time, and next sessions will be dealing or you'll be using R. I would just want us to go through the installation process and at least have R installed and also R Studio installed. It might take time, but I'm just going to give you the guidelines on how to install. You can do it later. We don't have to do it here because maybe your internet is not as strong as someone else, so we might take the whole time just installing. So for Windows, I'm going to post the link on the chat. Then for Mac, I'm just going to post the entire links on the chat. Let me just do that now. So this is Windows. Just extracting the link so that I share. Then we have Macs. Then we have Linux or Ubuntu. Yes, Regan, I can see your hand is raised, so you can go ahead. So I've just pasted the links to the installation. So depending on your OS, you can go for R installation. So that will install R. For R installation, you will go to the first one. If you have Windows, click on it and then choose the latest version on the website. So let me just see if I can do this. Stop sharing. I'll stop share. And then, yeah. Let me see if I can share these. Okay, so I'm just trying to share my screen. Okay, so I hope you can see my screen, and I'm just going to open this and then copy the link. So for Windows, you go to the first link. If you don't, just do this if you don't have R installed, but if you have it, you don't have to do it. So for this, the current version 4.33. So just click on it and you'll be able to download it. Then you just click on install. Then for Linux-based, for Mac-based OS, you just go to this particular one, and then you download the latest. So depending on your system, if you have 64-bit or 32-bit, you click on one of these and then you download. Then for Linux, those who have Linux always have more work to do. So for Linux, you'll have to run some command because it is not straightforward. So you open your terminal, then you run the first command, second command, and so on. I hope you can still see my screen. Are you able to see my screen?
Yes, I'm able to see screen.
Okay. Yeah, so for Linux system, it is not as straightforward for For Linux, in comparison to Windows and Mac, you have to run various commands, but I hope you are able to do that. If you are not able to, you can let me know, but just need to run each and every command here, and you'll be able to download various R version. So once you download R, that is one step. You don't have what we call the IDE or the editor. So R, let me just show you. Once you download it, you'll have something like this. I'll stop sharing and share again. So I'll open R. I mean, I don't have R installed. Apps. Okay, there's R. So I'll just share my screen so that once you download it, you can go to Start menu and then search for R. And once you open it, you'll be able to see something like this. So once you open it, you'll have something like this. It will show you the version. So this is version what, the name of the version, and so on. And you can now start working on it. So this is not ID, this is just R console. And you need to be good to be able to work on this without necessarily installing any text editor. So here you can do 1+3 and have your answer. You can do plot, you can say plot, maybe 1 to 10. This is just at least using R. Once you're able to do a few things like this, you know that it is installed. There will be other sessions which will introduce you to R, and they might even go through the installation process, but I just wanted you to at least have R installed so that you don't have to waste time in that. So this is R installed, but you need an editor. And one of the editors, or the best one for R, is called R Studio. I'm going to paste the link for R Studio installation, and you should be able to install R Studio. It was already posted, so I think, yeah, the last one. So no, I didn't post it. Let me just post it. So for R Studio, this is the link. Okay. Let me just check if there's any question. So there's a question of, I've started learning Python, but the basics. Do I need the basics to learn data science, or should I skip right away to the data analysis? It would be nice to go through the basics first so that you know every bit of the basics, then you skip to what you want to learn. But please go through the basics. You will help us how to install Starter if possible. Okay, so Starter, the only challenge with Starter is because it is paid and I don't have the license to share with you. So that would be a challenge. If you had your own and you're struggling to install, then that's a different story. Okay, so I've shared the link to RStudio. I'll just open it and then we can just see what you expect. You can download it later and install it. So share screen. Now I'll share this. Then so if you click the RStudio link, then it will redirect you to this. So it will again show you if you have Windows, what is this? How do you install it? If you have Mac OS, this version and above, how do you install it? If you have Linux, how to install it, and so on. So just download, click on any of them, and then you'll be able to download. So these are free versions. There's a paid version for RStudio server, but you are not interested in that. So just click on any of these and install. Any question? Any challenge? Okay, so I think at least you have the idea of how to install these particular softwares. I'll continue, go back to our slide and then see where we are. So where's slide? I think it is here. Share. I hope you can see my slide. Okay. So I think we are just at the end of it. And just to conclude, what we can say is that as we are interested in starting our journey or continuing our journey as data scientists, we just need to remember that we don't know where it will end. So what we can do is to enjoy the journey and embrace the destination when we get there. So when one time we get there where we say now, this is where everything ends, then we should just be happy when we are there. But in the meantime, let's just continue enjoying the journey, and please carry along other people who are interested, or go along with other people so that you can learn together. With that, I think I end my presentation, and thank you for taking time. I welcome any question. We still have some time for questions, and thank you so much.
Thank you, Steve. There's a question by Regan. I don't know that you're able to unmute yourself. Yes, Regan, you can ask your question.
Yes, I have a question. Can you hear me, please?
Yes, you can
Yes,
hear.
we can hear you.
Okay. Thank you, Mr. for your presentation. It's so the best presentation. But I'm a Regan Luvon, a medical doctor. I'm I'm an epidemiologist. I'm working in the area of mental health research in the Ministry of Health in Kinshasa, DRC. But for me, I think that the last year I used R and SPSS to start, but I want to be in the group of Python, and so yesterday I download Python and Visual Studio Code. I want to know how can I be head in the new group of Pythons. This is my question. Python, because I need to work with the Python.
Okay, so the question is, how can you be good in Python? Is that right?
The question is, how can I get or be in the group of the people who are working with Python as a software?
Okay, so that one is a good question, and I think we covered a bit of it on how we can start the journey. So one way is, the easiest way is to go to the Kaggle website and then just pick particular problems which are Python based. So they always say, okay, we want this solution to be in Python, we want this solution to be in R, and so on. So if you want to do Python, then pick a problem which is in Python, and there are always information about those who have registered to solve that particular problem. So you can start collaborating with them and even attending or having some group discussions around the problem you are solving. An alternative would be to just solve it by yourself on using Python. Then when it is time to submit, you submit, and then you have at least discussion with other groups and other people. The other option is there's a Python forum or Python page for help. There's always discussion forum. So for example, the same way we have Stack Overflow for R, there's Stack Overflow for Python. And in those platforms, there are always group people who are willing to learn together. Lastly, you can also form a group with your peers. So there are people who are also working in mental health, and they used R, and they also want to use Python. So you can start collaborating with them and then form a working group and do things together. I don't know whether that answers your question. Again, does that answer your question?